Okay, so first tell me about sine. What's its domain? All real numbers, it's range. Okay, 1 to -1 or -1 to 1. So when we look at sine of theta, we said domain, all real, range, -1 to 1. Now we're going to be looking at inverse of sine, or arc sine. Arc sine theta or sine inverse of theta. What do we typically do when we do the inverse with the domain and range? Okay, split them, yeah. Now, the problem is that going to be a function still? Let's think about what does sine look like? You look at the graph. You get something like this. If it just is the inverse, swapping x and y, is this going to be a function? No. However, we want to use a function for this. So what do you think we should do? Okay? Well, what we end up doing is create a standard of saying, let's just cut it off right here, and cut it off right here. So what would the domain of this be? Where is sine at its lowest point? Well, it is -1, but what's the x value? Negative. Where is sine equal to -1? -π². So we go from -π², and what would the highest point be? +π², because that's where sine equals +1. So we treat this as a -π² to π², and then range. Notice within those range things. What's the range? Still -1 to 1, which is what our goal is, to maintain the entire range, but only look at a single part of the graph. So now when we look at the inverses of them, what do you expect the domain of the inverse to be? -1 to 1, and your range? Okay. Does that make sense how we did that? Yeah. As always, when we're doing domain range, you stick inverse, you split x and y. Remember, to find it, all we did was, one of the key steps is swapping x and y. What do you think is going to happen for cosine? If we did the simple graph of cosine, where does cosine start at? 1. And continues this pattern. What's the domain of cosine, normal? Okay, all real. What's the range? Okay, so remember when you see arc cosine is the same as doing the cosine inverse, so I don't need to write down both of these. So these are the equivalent. So where it might be convenient to cut cosine off is the same way we cut sine. Okay, would it make sense to do π² to π from here to here? No, because we still want to get a function. We did the inverse. So what would be convenient? Okay, 0, that's where it's at the highest point, to π, where it's at the lowest point. So, if we did domain 0 to π, what's the range then? Okay, same as y, so -1 to 1. So if we did the arc cosine, what's the domain going to be? What? What do you think? swap it to what it can be. Yeah, negative 1 to 1, just like did before, swapping these. A range 0 to pi. Okay. Now, tangent gets a bit more interesting. The tangent of theta. What's the domain of tangent theta? Oh, it would be all real except all these undefined points, right? So what might be a convenient limitation for it? Okay? How about from between one of the two of these, right? And where is the tangent undefined at? Negative pi half, and this would be? So, does it include those two? Okay, so it's negative pi half to pi half, and your range, all real. Now, are we going to have to do anything funny to make it work for as an inverse with the all real? Because with notice we have to do that with sine and cosine. We have to make limitations when there is all real. Do we have to do the same here? No. Why not? Because it's in the y, not the x. Okay. So what's the domain of arc tangent going to be? Okay. Okay, all real. So just swapping it up here. And your range? This means when we take the arc cosine of something, is my answer going to be positive or negative? Or can you tell? Yeah. Yes. Brackets mean it includes the point, technically, so that it doesn't.
And so
So yeah, we can't actually reach negative pi half, whereas we could reach 0. How about this? Arc cosine of negative root 2 over 2. So you're going to have questions like this. Possibly on the test, but on the homework, you should be able to do without a calculator. So where does the cosine equal negative root 2 over 2? When you start looking at your circle, where on here is that true? Okay. Now you have one right here, and one right here. Now, which one is it going to give as an answer? Okay? It's going to give this answer here, 3/4. Because when you look at it, you say cosine is between 0 and pi. All the answers when you plug in our cosine. So this angle right here, it will also give you 3/4 if you did the arc cosine of, or to get that. So sometimes you might have to be careful as to which quadrant you're in. So if I said quadrant 3, arc cosine is of negative root 2 over 2 in quadrant 3. We'd be able to say which angle we have now. However, if you just plug this into your calculator, you're going to get this angle out. So this would equal 3 pi over 4, or as degrees, what do you get? 135 degrees. How about this? Arc sine of 3. So at what angle does sine equal 3? a, want to take a guess? It can't, he says. Why? Yeah, you know, the inputs you can put in are -1 to 1. So this is undefined. There's no number that will give us that you can take the sign of and get 3. Well, for example, we could, if we were, we could say sine of some angle theta is equal to 3. The sine of what angle is 3? It doesn't, because we know sine is between -1 and 1. So if you look at this one, arctangent of 1. Where is tangent equal to 1? However, which numbers are in the range? So where is tangent equal to 1? Okay, pi fourths, so right here. And 5 pi fourths. You notice it would be negative here. So which one would we get? You look at the range of the arctangent. So which one is it going to give? Pi fourths. Okay? Because this is, if we went down here, I'm going to highlight some stuff here. Let's go back here. And on the unit circle, so notice, what is the domain of sine? Okay? So, and we went from -pi½ to pi². So sine does only answers over here. So that gives us where our sine is coming from. Do you understand what I mean by that? So if I do the arc sine of any number, it will give me an answer between -pi½ and pi². If I did cosine, that's for instance, I have to go between 0 and pi. So I'm going to always get answers in this part. If I do the arc cosine of something. And where's tangent? Again, it's the same as this. The tangent and sine both give the same answer, give the same range. So what is the arc sine of √3/2? Or √3/2. Arc sine of √3/2. Everybody got an angle figured out? What angle will get you √3/2? Okay? 60 degrees. So, is sine √3/2 here? Yeah. So this would give us this would give us 60 degrees or pi squared. Now, if I did the arc cosine of √3/2, what would I get? I would get this one right here, which is 30 degrees, or pi seconds. Man, what about graphing these? The graph's actually a bit easier, I think, than doing the regular graph. So let's see, if I did just y equals arc sine of theta. And what is the domain for arc sine? What? That's
oh, -pi to 4.
the domain.
Oh, the domain, yeah,
-1 to 1. Yeah. sorry. So, negative 1 to 1. What's the range? Negative pi over 2 to pi over 2. Pi over 2. Okay? So, what that means is our entire graph is going to fit in that. And that's the advantage of the arc sine, arc cosine, arc tangent. Is once you get this, well, tangent is a bit different, but arc sine, cosine, once you get this set up, we know what the domain of range is. It is limited in there. What is the arc sine of 1? So, or arc sine of, sorry, negative 1. Arc sine of negative 1. So what is that? Where does sine equal negative 1? 270 degrees, which is where between negative pi half and pi half? Negative pi half. 270 degrees is the same as negative pi over 2? Okay. So, negative 1, negative pi over 2. How about positive 1? Pi over 2. But 0. Okay. Now what happens between them? Here if I do, let's see, I call this negative pi over 4. What is the sign of negative pi 4? Okay. Negative root 2 over 2. What is negative root 2 over 2 as a decimal? Okay, root 2 is about is 1.4. So 1.4 divided by 2, 0.7, so about negative 0.7. So here, negative 0.7 would be somewhere around there. Okay, this would be 0.75, so probably closer there. What if I did, let's see, where would pi 6 be on here? How about there? It'd be, I divide into 3 parts, so somewhere in there. So what is the sign of pi 6? Okay, and what would be the sign of negative pi 6? Yeah. Negative 1/2. And we could mirror these up here at the top. Say we want 0.7, and then middle here. So we get a graph like that. And our cosine would be the same sort of idea. Once you get this domain and range set up, you just know all your entire range has to be in there. Tangent is a little bit different. Why is tangent different? What's the domain of tangent? Yes, you have to do some graphing. Not necessarily, as long as you know how to do it. What is the range, or what is the range of tangents? How wide does it go? Or arctangent, sorry. Okay, so negative pi half to pi over 2. And it's all real, but we have asymptotes with these. Both of them. Yeah, but this time our horizontal asymptotes instead of vertical. And we know it's going to go through 0, 0, because the tangent of 0 is 0. And what's the other part going to look like? So pi 4. What is the tangent of negative pi 4? Tangent of negative pi 4? 1. So I know it's going to be here. And tangent of positive pi 4? 1 again. And so we get same sort of thing we had before on tangent. Yeah. And if you did arc cotangent, you get the same idea. Just a little bit shifted and vertically flipped. Now, the hard part. Okay, I like it better. The algebra part. Who likes algebra better than graphing? Who likes the graphing better? Okay. So, sine of the sine inverse of, let's see, 3 or 4. Or it's actually 2. 3 pi over 4. Make it be. What is it equal to? 3 pi over 4. How if I did the cosine of the arc cosine of 5? Undefined. You can't do the arc cosine of 5. Right, cosine of the arc cosine of 0.2. Exactly. Yes. Now, the complicated part. Those are the easy ones. How about the cosine of the arc tangent of 1? What is the arc tangent of 1? Okay, so 45 degrees. Or pi 4. What's the cosine of pi 4? Yeah. So this one we first did what is the arctangent of 1 and got pi 4. And then cosine of that answer. There you follow us? Okay. Just work from inside to out, order of operations. Now, the more challenging section. These ones you may need to draw a triangle for. The tangent of the inverse cosine of x. Now I want an algebraic expression. What I would suggest when you're doing this is draw your triangle. And what is x, or what is cosine in terms of opposite adjacent hypotenuse? What is cosine in terms of opposite adjacent hypotenuse? What? Yeah, adjacent over hypotenuse. So I'm going to put my angle down here just to make it fitting with the unit circle. Now, adjacent over hypotenuse is x over 1. That's because of the cosine part. Yeah. Now, we need to get the tangent of this angle. So how do we get the third side of this triangle? 1 squared minus x squared. So 1 minus x squared is the square root of it. Oh, not quite. So we can say x squared plus, let's say, m squared equals 1, right? And our goal is solving for m. So m squared equals 1 minus x squared. So m equals square root 1 minus x squared. So this becomes the square root 1 minus x squared. Now, what is tangent in terms of opposite adjacent hypotenuse? Okay, so what is opposite of my angle? That's up, right? So 1 minus x squared over adjacent. X. And there's my answer. What? Well, this can't really simplify it, so that would be done. Okay, let's do another one of these. A question? Why is it divided by x? Because remember, our original thing said the tangent of the inverse cosine. Inverse cosine gives me this angle. So this right here tells me theta. And I need a tangent of it. So how about the sine of the arc cosine of, say, 1 over x?
I don't know. 1 over x squared.
Okay? So, how do you do this one? I would again, just like before, start off with my triangle. Theta. Cosine is what in terms of opposite hypotenuse? Okay, adjacent over hypotenuse, so 1 over x squared. And now I need to get my third side. How do I get it? So it's x squared minus 1. Square root of x squared minus 1? No? So, 1, yes, x to the 4th minus 1. Square root x to the 4th minus 1? No? Yes? Okay. I think 1 squared plus m squared equals x to the 4th, so x squared squared. Subtract it. So, square root x to the 4th minus 1. Now, how do I get the sine of the angle then? Opposite over hypotenuse, so I have square root x to the 4th minus 1 over hypotenuse, x squared.
How come last time you subtracted the x and the other one?
Okay? Notice, where is x in this one? Your hypotenuse.
Oh.
It's because I arranged it differently. And that's because here I had x, so it was x over 1. I could write this over 1, and then adjacent hypotenuse. Here, it is 1 over x squared, so it's 1 x squared.